Picking back up where we left off in the first video, the question on etcd.io docs in the FAQ operations section is how to back up a etcd cluster. Well, etcd control provides a snapshot command to create backups. See backup for more details. So that's just incredibly straightforward. Use the etcd command snapshot to back up your stuff. Next, should I add a member before removing an unhealthy member? When replacing an etcd node, it's important to remove the first and then add its replacement. Etcd employs distributed consensus based on a quorum model. We talked about this in the first video. So a majority must agree on a proposal before it can be committed to the cluster. These proposals include key value updates and membership changes. This model totally avoids any possibility of split brain inconsistency. The downside is permanent quorum loss, which is catastrophic. Too bad the docs aren't on GitHub, or I would open a pull request to fix that grammar. I will skip this paragraph because they just give the details as to how that all works. They say that a new member is risky because it may turn out to be misconfigured or incapable of joining the cluster. In that case, there's no way to recover quorum because the cluster has 2 members down and 2 members up, but needs 3 votes to change membership to undo the botched membership addition. etcd will by default reject member add attempts that could take down the cluster in this manner. On the other hand, if the down member is removed from cluster membership first, the number of members becomes 2 and the quorum remains at 2. Following that removal by adding a new member will also keep the quorum steady at 2. So even if the new node can't be brought up, it's still possible to remove the new member through quorum on the remaining live members. Right? Why won't etcd accept my membership changes? etcd sets strict-reconfig-check in order to reject reconfiguration requests that would cause quorum loss. Abandoning quorum is really risky, especially when the cluster is already unhealthy. Although it may be tempting to disable quorum checking if there's quorum loss to add a new member, this could lead to full-fledged cluster inconsistency. For many applications, this will make the problem even worse. Think about disk geometry corruption being a candidate for the most terrifying. Why does etcd lose its leader from disk latency spikes? This is intentional. Disk latency is part of leader liveness. Suppose a cluster leader takes a minute to fsync a raft log update to disk, but the etcd cluster has a 1-second election timeout. Even though the leader can process network messages within the election interval, for example send heartbeats, it's effectively unavailable because it can't commit any new proposals. It's waiting on the slow disk. If the cluster frequently loses its leader due to disk latencies, try tuning the disk settings or etcd time parameters. Next up is, what does the etcd warning request ignored cluster ID mismatch mean? Every new etcd cluster generates a new cluster ID based on the initial cluster reconfiguration and a user-provided unique initial cluster token value. By having unique cluster IDs, etcd is protected from cross-cluster interaction, which could corrupt the cluster. Usually this warning happens after tearing down an odd cluster, then reusing some of the pure addresses for the new cluster. If any etcd process from the old cluster is still running, it will try to contact the new cluster, and the new cluster will recognize the cluster ID mismatch, then ignore the request and emit this warning. This warning is often cleared by ensuring peer addresses among distinct clusters are disjoint. So is that like a state it is in? Well, I like error messages, so let's read another one. What does MVCC, database space exceeded, mean? And how do I fix it? Well, the multi-version concurrency control, get it, MVCC? Data model in etcd keeps an exact history of the key space without periodically compacting this history. For example, by setting auto compaction, etcd will eventually exhaust its storage space. If etcd runs low on storage space, it raises a space quota alarm to protect the cluster from further writes. So long as the alarm is raised, etcd responds to write requests with the error that we read at the beginning of this, MVCC database space exceeded. To recover from the low space quota alarm, you could click this link, compact etcd's history, defragment every etcd endpoint, that'll take you back, and number 3, disarm the alarm. Alright, that'll be it for this video. In the next one, we'll look at this beast.